Lesson 10, Part 1, Question 1. What is a confidence interval? A confidence interval is simply, it's an interval between two numbers, which estimates a population parameter. So for example, if we were talking about the score on a test and we wanted to show the confidence interval, let's say our mean, our population parameter, was, let's say, 77. A confidence interval might look like 74 to 80. Okay? So this parentheses between these two numbers shows our confidence interval. That this is our average, and we know that we're really confident that it's between these two numbers. Question 2. What is the margin of error in a confidence interval when estimating the population mean? Okay, so if we're going to estimate the population score on this test, then we could say that it's between 74 and 80 for the population. Now, our margin of error is the distance between this mean and then the high and the low of the confidence interval. So in this case, it's down 3 and up 3. So we have a margin of error, which is normally represented by m, of 3. Question 3. Assuming you know sigma, what is the general formula for a confidence interval used to estimate the population mean? Okay, so the formula to find your confidence interval is your x bar minus, well, plus or minus your z, which we're going to talk about in question 5, what that z is, z times sigma divided by the square root of n. Okay? Now the minus is how you get the left side, and the plus is how you get the right side, the right number. Okay? And remember that this part right here is your n. Question 4. What are the assumptions for creating a confidence interval for a single mean with sigma known? And there are 3 of them. 1, it has to come from a simple random sample. 2, the distribution of the sample mean is normally distributed. Okay, now we could test that by either the central limit theorem, if we have more than 30 in our data, or we have to do a QQ plot. And then 3, sigma must be known. So it says, question 5. Open up your normal probability applet and answer the following questions. A. Go to the normal probability applet and type in 0.90 for the area. Shade the middle area under the curve, leaving the 2 tails unshaded. So we're going to shade that middle part, and for the area, we're going to type in 0.90. Okay? Now that gave us the z that we're going to be using in our margin of error. So A is 1.645. B, go to the normal probability applet and type in 0.95 for this area. So change the area to 0.95. This middle represents our p-value, but we're going, Question B, B. Go to the normal probability applet and type in 0.95 for this area. Okay, so we typed in 0.95, shaded the middle area, and then this number right here becomes the z that we'll use in the margin of error. C. Go to the normal probability applet and type in 0.99 for the area. Okay, we type in 0.99 and we get a 2.576 for the z. Now these are the z's that we'll be using for the margin of error. Question 6. What are the 3 assumptions that need to be checked before you compute a confidence interval for a mean? Now there are 3 requirements that we must check before we do the confidence interval. The first one is that the sample was collected by a simple random sample. The second is that the distribution of the sample mean is normally distributed, and C sigma is assumed to be known. Okay, and so the sigma is known, tells us we're going to be doing a z-score, and B, the distribution of the sample mean, is normally distributed. So and we can know that by if we have a sample size bigger than 30, which is the central limit theorem, or we can use a QQ plot to test that. Question 7. What is the point estimate for the population mean? Okay, so our estimate of the population mean is 541. Okay, so we're going to use the sample mean, what we collected from our sample, to estimate what it is on the bigger scale, or the scale of the population. So our sample mean was 541, so that's an estimate of what the population must be. Question 8. Create a 95% confidence interval for the population mean. Show all of your work below. Okay, so for the confidence interval, we remember our equation is x bar plus and minus the z that we got from question 5 in part 1 times the standard deviation divided by the square root of n, which is our sample size. Okay, so in this case, our sample mean was 541, and we'll first do minus the 1.96, which is what you get on the z-score on the normal probability applet if you plug in 90.95 as your area in the middle. And so remember, that's with a 0.05 level of significance. Our sigma, we know, is 32, because that is given, and the square root of our sample size being 50. Okay? And then on the other side, we just write the same thing, 541, except for this time it's plus the margin of error. Okay? That becomes our confidence interval. And if you plug that into your calculator, you'll get the numbers on the answer sheet, which is 532.13 and 549.87. Okay? So now what this is saying is that for our sample, we saw that it was 541. Now we want to take that sample mean and we want to project it to the whole population. We want to know what conclusions we can find. So our confidence interval, with this we can say that we're 95% confident that the true mean of the whole population is somewhere between 532 and 549. And that's the purpose of a confidence interval. Question 9. Say that the sample size changes to 100. Now compute a 95% confidence interval with the same point estimate. Okay, so in this case, we're going to just switch just one number on both sides, and we'll get a different confidence interval. And that number is we're going to switch the sample size. So what happens to our confidence interval if we increase it to 100? Now let's try and think about this before we actually do the calculations. So if we increase the denominator, then that should make this number smaller. Okay, so let's see how that comes out when we plug it in. And as a matter of fact, it does. We get approximately 543. You can look on your solutions to find the exact numbers, and 547. Okay, so it did shrink. So our confidence interval is from there to there with a bigger population. Now question 10 asks, how does the margin of error for the 95% interval of sample size 50 compare to the margin of error for the 95% confidence interval of the sample size 100? Okay, so now if we compare for the 100, and then when we had a sample size of 50, it was 532 to 549. Oh. Okay. So we notice that what happened when our let's just try this again. Question number 10. How do they compare? This is how they compare. In our population, when our sample was size was 50, we had 32 to 49. When we increased the sample size, we got a smaller range from 34 to 47. Okay, and that makes sense, right? The more people that you survey, the bigger your survey is, or the bigger your sample is, the more accurate it's going to be, or the better able you are to predict what the population is. So that's why we shrunk from 32 to 49 to 34 to 47. Okay, so that this part right here, the margin of error is getting smaller. Question 11, create a 90% confidence interval for the original 50 students. Okay, so this time we're going to change that. Now that we have a 90%, so we're going to change this back to 50. And then can you think of which number is going to switch? It'll be this middle one. Okay? The Z, because now we've changed on the normal probability applet that middle area, and so that changed our Z score for it, which now goes to 1.65. So 1.65, and when you plug that into your calculator, you get 533 and 548. Okay. It's question 12. So how does that compare? So what happens when we change this number? Well, at the first time that we did it, this was a bigger number. Okay, so our margin of error was larger. Okay, so when you take a number and you subtract a big number, then it goes far out, and you take that same number and you add a big number, it goes pretty far out. But if you make that distance smaller by making this number smaller, because remember, to start with, it was 1.96. Now it's 1.65. We're going to shrink. It's going to move in. As our margin of error gets smaller, our range of our confidence interval is also going to shrink. The BYUI professor would like to repeat the experiment, but he wants to make sure he has enough students in his sample to ensure that his margin of error is 5. Okay, how many students will need to be in his sample to ensure he has this level of accuracy for a 95% confidence interval? Okay, so algebraically, if we were to rearrange this equation for solving for n, because now that's what we're looking for, instead of looking for just the m up here, or this part right here equals m, now we're going to switch it around to solve for n, and when you do that, you get z times sigma divided by m, and all of that squared. You can kind of see how that might work here as you take your n and your m pretty much switch places. The square root turns into a square. And so if you want to work that out algebraically, I encourage you to do that with that piece right there. Okay, but now that once we have that, then it's pretty easy, just plug and play. So we've got a z-score here. We're talking about with a 95 or with 0.05 alpha level, we have a 1.96 times our sigma, which hasn't changed, 32. If we want our m, which remember is our margin of error, to be 5, then you can plug that into your calculator, and the number that you get will be the minimum number of sample size that you need to get to that margin of error. Okay, so when we plug that in, we get 157.3. Now be careful here because you can't have a third of a person, and so we need to round that up, but we need that 0.3, so we always round up to 158. Okay, so if we want our margin of error to be 5, meaning you're going to add 5 and subtract 5 from your point estimator in order to get your confidence interval, then we need to sample 158 students.